In this video, we're going to have an introduction to algebra. So far in our studies, we haven't actually gotten to algebra. We were just looking at arithmetic, learning how to add, subtract, multiply, and divide numbers, and some of the properties that come from that. Now we want to get to algebra. The difference between arithmetic and algebra is one main word at this point, and it's a variable. All right, a variable is basically any object or symbol that represents a number or a quantity. All right, so far we've had stuff like 2 plus 5, right, or 3 minus 7. Now we're going to, instead of having these numbers, or instead of both of these being numbers, now we're going to put a variable in one of their places. Still, the same stuff still applies, but now we might have 2 plus x instead of 2 plus 5, and we might have 3 minus x instead of 3 minus 7, all right? Of course, in order for us to use variables, we're going to need to be able to convert stuff into looking like algebraic expressions, all right? And basically, an algebraic expression is an expression with some arithmetic symbols, arithmetic operations, adding, subtracting, multiplying, dividing. It may have parentheses, it may have exponents, and a variable in it, all right? And so these are algebraic expressions, and we want to be able to go from writing words to having actual algebraic expressions. For instance, in part A, we have 9 more than a number. I want to be able to write a mathematical representation of 9 more than a number. Now, if you notice here, I have this part right here that says a number. Of course, we don't know what that number is. That's what our variable comes into play. So I'm going to call that number x. If I want to write 9 more than x, then all I have to do is add 9 to x. So the algebraic expression for 9 more than a number is x plus 9. All right, let's go to part B. A number decreased by 25. All right, again, we have that term or that phrase, a number. All right, of course, since I don't know what that number is, that's where my variable comes into play. I'm going to call it x. A number decreased by 25 means I'm going to have to subtract 25 from that number, right? So it's going to be x minus 25. Notice the order is definitely going to matter here, all right? When you subtract something, the order does matter, all right? But when you add something, the order really doesn't matter. So in this case, I could have written 9 plus x and it meant the same thing. But with subtraction, I can't switch the order. This is not the same thing. It's not equal to 25 minus x. That is 25 decreased by x, not a number decreased by 25. So I'll never write it like that. Let's go to part C. Twice a number. Again, we see that a number part. Twice something is just multiplying that thing by 2. And so twice a number, and if I'm calling my number x, I'm going to have 2x. All right. Part D, the quotient of a number. There's that a number stuff again. A number and 20. The quotient. Quotient means division. And so if I'm going to have a quotient of a number and 20, I'm going to have to take that number and I'm going to have to divide it by 20. All right. One thing that you're going to start to see is instead of using this division symbol, we're pretty much going to be using fractions for division. All right. But these 3 examples give examples of addition, subtraction, multiplication, and division, and how they may be written in words and how we can actually translate them into algebraic expressions. Now we're going to look at an example where we actually look at a real world problem and changing that into an algebraic expression. The problem reads, it says, a rental company rents moving vans for $20 plus 15 cents per mile. Letting M represent the number of miles, build a variable expression for the cost to rent a moving van from this rental company. All right. So it's going to cost you $20 plus 15 cents per mile. And we want to build a variable expression, and it says to let M represent the number of miles. All right. So M represents the number of miles right there. This is going to be my M. Well, my cost, automatically, I'm going to have 20 $20. And then it's going to be plus 15 cents per mile. All right, well, plus, that's addition. And when I say per mile, that means for 15 cents, every single mile that I go, I'm going to have to add another 15 cents. So if I go 1 mile, that's going to be 15 cents. If I go 2 miles, well, that's going to be 15 cents plus 15 cents, or 2 times 15 cents, which is 30 cents. Right? If I go 3 miles, that's going to be 3 times 15 cents. So if I kind of put all that stuff together, it's going to be 0.15 times the number of miles, and my miles is given by M. All right. One thing that I didn't mention before, when it comes to multiplication, right? In this part C up here, we have twice a number, and I said that we multiply the variable x by 2, right? Notice that I did not put a multiplication symbol between the 2 and the x. It is actually understood to be there. All right. Likewise, when I have this 0.15 times m, notice that I didn't put the multiplication symbol there. It is understood to be there. All right. So we get 20 plus 0.15 m, and this is actually my final answer here. Right. So if I ever want, if you're a boss or you own a company that does, that rents vans, then you can use this knowledge of algebra right here, so that if someone comes and asks you, okay, well, I want to rent the van. Well, how much is it going to cost me? Well, you can say, oh, it's going to cost, you just put however many miles that the person tell you that they want to drive into that variable expression right there, and then you'll be able to give them an estimate on how much it's going to cost. Now, we're not taking in any taxes or any fees or anything like that into consideration, but this is kind of the basics of where you will start. All right. So now that we know how to build variable expressions, we actually want to be able to do something with them, right? This 20 plus 0.15 m is not important. It's not going to be useful unless we can actually use it. I know that's a weird way of putting it, but it means nothing unless we can use it. All right. And so that brings us to what we call evaluating variable expressions. When I say evaluate, what I mean is for you to substitute the value in for the variable. All right. And I have an example down here, x squared plus 5x minus 18. So this is my variable expression right here. I want to evaluate that for x equals -4. All right, so I have this expression, and I want to evaluate it for x equals -4. Well, since evaluate means substitute the value in for the variable, I'm going to substitute this -4 in for x. So here where I see the x squared, I'm now going to have a -4 squared. Where I have the 5x, I'm going to have a 5 times -4, because that 5 times x, that's multiplication. And I still have minus 18, excuse me. Now I need to simplify this so I can get a final answer. And of course, when I simplify, I have to use my order of operations. Of course, we have parentheses, but there's no operations inside of the parentheses. So I'm going to go to exponents. That's -4 squared, which will be 16. And actually, since they're separated by a plus here and a minus here, let's erase that so that we won't get confused there. Since those are true, then I can actually do this at the same time. So I'm going to go ahead and multiply the 5 and a -4, and I get -20, and I have minus 18. Now I add and subtract from left to right. Okay, so I have 16 plus a -20, which is a -4, minus 18, and -4 minus 18 equals -22. All right, and so that's evaluating an algebraic expression. Now I would like to talk about what we call the distributive property. All right, so we've actually talked about a couple of properties before. One of the properties is that I can switch the order when I add, but I can't switch when I subtract. You can also switch the order when you multiply, but you can't do it when you divide. But the distributive property is going to be very useful for us throughout this course. All right, distributive property says if I have real numbers a, b, and c, then if I have this setup here where I have a and then a parentheses b plus c, of course between the a and that parentheses is a multiplication, so that's a times the sum of b and c, then I can actually distribute the a to both the b and the c to have a product that looks like this. AB, all right, so I'm going to multiply a times b. I'm going to keep that sign in the middle, and I'm going to multiply A times C. All right, this is called the distributive property, which we'll use over and over and over again. Let's look at an example of using the distributive property. It says simplify 7 times 5x plus 4. Well, I have to distribute the 7 to the 5x. That'll give me 7 times 5 is 35x. All right. And notice when I go to do the 7 times 4, I get 28. So I have 35x plus 28, and that is it. Okay. So notice that I multiply the 7 and the 5, and I put it still in front of the x because 7 times 5 is 35, and if I multiply 35 by x, I'll still have this 35x here. And then I didn't have to do anything with a variable with the 4 because it has no variable. So it became 7 times 4, which is 28. All right. Last thing we want to talk about in this section is what we call combining like terms. All right. Like terms are basically variable expressions, or terms are basically variable expressions that have the same variable. For instance, 2x and negative 4x are what we call like terms. All right, they have the same variable part, and they just have a number multiplied in front of them. That's what we call a like term. Something like 2x and negative 4y would not be considered like terms because the 2 has an x and the negative 4 has the y. All right, so those are not like terms. And when I say combining like terms, we're going to add or subtract the coefficients, oh, there's a new word, of the terms with the same variable. What I mean by coefficients is the numbers that are in front of the variable. For instance, with this 2x and negative 4x, my coefficients are 2 and negative 4. Those are my coefficients. All right, let's look at an example where we simplify by combining like terms. All right, in this example, we have 4x plus 3y minus 2x plus a negative 5y. We want to combine like terms or simplify. Well, first, we've got to look at our like terms. For instance, this 4x and this minus 2x are like terms, and the 3y and negative 5y are like terms. And so if we're going to combine like terms, then we need to be able to look at 4x, and I have a minus 2x. If I can do 4 and that minus 2, I'm going to get a positive 2. All right, so I did 4 and that minus 2, but I can't forget the x. So I have 2 times x. And now I'm going to get to the 3y plus the negative 5y. Well, 3 plus a negative 5 is a negative 2. And we can leave it as negative 2y. All right, and so we have 2x minus 2y. And actually, what most of you probably would have wanted to write was plus a negative 2y. And actually, instead of having these double signs next to each other, we want to leave it like this. All right. We're going to look at one more or a couple more examples where we put both of these things together, the distributive property and combining like terms. All right. In this example, before I try to combine like terms, I have to do my distributive property. So I'm going to distribute that 4. So I'll get a 12x minus 28. Sorry about that. That's a 28 plus 2x plus 6. All right. Notice here, like terms here. And then I have like terms there. All right. So when I simplify this, I'm going to have a 12x plus 2x, which is 14x. And a negative 28 plus 2, which is a negative 22. So this simplifies down to 14x minus 22. I stopped there because they're not like terms. 22 does not have a variable part. Last but not least, part B. And actually, we're going to save this for class. All right. So this ends our video on the introduction to algebra.